MapReduce scheduling service architecture. So it is mainly divided in this particular MapReducing runtime support for the execution of MapReduce job is constituted by the collection of different services. So that mainly that was mainly dealing with the scheduling and the execution of MapReducing task. Okay. So now these MapReducing services, what they are going to have is going to be discussed in today's class. So there are one MapReducing scheduling service will be there. Other is the execution service, as we have discussed. So any of any MapReduce model, if you take, so there are two. It is going to provide you the two services. What are the two services? One is your scheduling service. Other is the execution service. So here also in Aneka, if you take, so it is going to provide you the two different services. So the two different services which the Aneka is going to provide is one is your MapReducing scheduling service, and the other is MapReduce execution service. Now, when you take these two services, what this is going to provide? So these two services is going to integrate with the existing services of the framework. So in order to provide you the clear picture of what is happening and how the application is going to run, how the accounting is going to be taken, and what are the different features it is going to have, and what are the applications which can be developed with respect to the other programming models. So that particular task it is going to take. So now if you take or talk about your job and scheduling, task scheduling in your Aneka, so it is going to basically what it is going to do. So if you talk about the scheduling of the job, so basically it is going to be done by the master worker in your Google MapReduce. Okay, so if you talk about the Google MapReduce implementation, so that will be taken care by the master process. Okay, so here also the same thing which will happen here. What is going to happen here? The scheduling of jobs and tasks is the responsibility of MapReduce scheduling service. So if you take the scheduling of the task, that particular scheduling is be taken care by the MapReduce scheduling service. So whatever we are showing here, this is nothing but the MapReduce scheduling service architecture. So now which this particular service is going to play the same role what we have discussed already in your Google MapReduce implementation. Okay, so now so it is going to be organized. If you take the MapReduce scheduling services architecture, so your MapReduce scheduling architecture is organized into two major components. Okay, so it is going to be organized into two major components. What are those components? One is your MapReduce scheduler service. This is one is your MapReduce scheduler service, and other is your MapReduce scheduler. So these are the two services which is organized, and it is containing two major components. Those are the two major components what it is going to have. One is your MapReduce scheduler service. It is going to have. Other is your MapReduce scheduler. So now, if you take the MapReduce scheduler service, as you can see here, so that will become the wrapper class for your MapReduce scheduler. So that you can see it from the figure. So your MapReduce scheduler service is nothing but what? It is nothing but the wrapper class for your MapReduce scheduler. So now this will be implemented with the help of the interfaces. Okay, so we are going to have the interfaces. So when you are going to have the interfaces means what? So you are going to have the inherited from other classes. So you are going to have the interfaces that will be done by your Aneka. So for what purpose they are going to make use of that particular Aneka? To expose a software component as a service. So that particular software service which you are going to have, so it has to expose this. Okay, and whatever the controls are there within this particular MapReduce scheduler, like your upload queue may be there, whether it may be initialization queue are there, dispatch queue is there, failure queue is there, resubmission queue is there, reporting queue is there. Okay, so these are controlled by your execution of jobs and schedules tasks. Okay, so now the main role of the service wrapper is to what? It is to translate messages coming from the Aneka runtime or the client applications into the events. Okay, and it is going to be directed to the scheduler components and vice versa. It's going to happen. So now these two relations which you are going to have from Aneka middleware to the MapReduce applications to the scheduler servicing architecture. So that will be the execution services will be mapped here. Okay, that will be mapped by using the MapReduce scheduler service, which is acting as a wrapper class. So that will be acting as a wrapper class for your MapReduce scheduler. For what it is going to happen as a wrapper class, it is going to work as a wrapper class for your MapReduce scheduler. Okay. So in the MapReduce scheduler, as you know, so whatever the task you are going to provide, that will be uploaded here. So the scheduler is going to schedule that which one has to run first, second, because I have to run the task. So the master has to first allocate the task, right? So first it is going to upload the queue. So depending upon the priority of the task, so that has to be uploaded. So similarly, which task has to run first, which task has to run second, so which task has to run third. So that will be uploaded here. So the next, it is going to have the initialization queue. Okay, so the initialization is nothing but what? So these are the necessary parameters which you require for that particular thread to work. So if anything has to be done, means what? I want some information to be there, or some task, some data should be there to work that one. So what are the necessary initialization it requires? What are the things it requires? Next, once it is initialized, I'm going to dispatch that one to the worker node. So I'm going to dispatch to the worker node. So once it is dispatched, for some reason, if that thread is not going to run, okay, if there is a failure in that particular thread, what I need to do for that one? So that if any failure is happening in that particular scheduler, or whatever the task you have been scheduled, or whatever the task you have been uploaded, so once the task start running and initialized, dispatched, so if for some problem, if that particular resource is not available, so I want to run something, some application, that application's resources is not available. Okay, so if it is not available means what? That task cannot run. So if it is not running means what? It is a fail. So that means it does not got the sufficient resources. Since the resources are not there, it is going to be failed. Okay, so now your failure queue will, what it is going to have? The failure queue will take the tasks which have been not completed. Okay, so now it will list out which are the tasks which has been failed to run. So then it will queue up in the failure queue. Okay, it is going to have the queue, and it is going to queue up which are the tasks which have been not run, or which are not having the enough resource to run. So it is because due to a synchronization problem, it may not able to run at that particular instance of time. So for that particular reason, it may end up with what? In the failure queue. So once it is done with the failure queue, now what will happen? So after some time, the resources will be released by other process, which will be acquired by some process, right? So once those resources are available, so what I need to do? The same tasks which are there in the failure queue have to be resubmitted. Okay, so whatever the task which is already there in the failure queue, that particular task which are there in the failure queue have to be resubmitted again, and it has to be run. Okay, so once everything is completed, all the tasks which has been uploaded, okay, so then if all the tasks are completed, now what I need to do? I have to report it. Okay, so these tasks are completed, and I have to tell that, so these are the tasks which have been uploaded, and these are the tasks which have been already completed, and some tasks which have been already going on. So thus reporting queue will be there, that will keep track of reports of all the tasks. So whether that is in which state, whether it is a running state, or whether it is in a waiting state, or whether it is in delayed state, whether it has been completed. So that particular report has to be generated, right? So that particular reporting will be there in your reporting queue. Now, so this particular architecture, so initialization jobs for scheduling, so scheduling the maps and reduce tasks, which will be done here. Okay. So now all these operations will be done asynchronously. Okay, what do you mean by asynchronously? Because since it is not happening at the same time, because your upload queue, initialization, dispatch, failure, resubmission, reporting, all cannot be done at the same time. So one after the other only it has to do, right? So if you upload, after uploading the queue only, that particular, for that particular task, I have to initialize it. So that is going to happen in that particular fashion, one after the other. So first it is going to upload. So this will be first happening. So second is going to initialize. Third, it is going to dispatch. So once it is dispatched, if non-availability of the resources is there, so non-available of resources, then it will, that particular task will be sent to the failure queue. So once once all are completed and resources are available, so whatever the tasks which are there in the failure queue, what will happen? Again, it will be sent to the resubmission queue. So in turn, the resubmission queue, what it will do? It will send that particular data to dispatch to work. Okay, once that particular, when it is going to send that particular task available, that particular task is into the dispatch thread to dispatch to run that particular task. Okay. So next is your reporting queue. As I told you that it is going to keep track of the reporting. So all these things has to be taken care by whom? Taken care by your Aneka hardware. So it is going to be taken care by your hardware. So whatever the data you are going to take, so that particular data will be in DFS. Okay. So what do you mean by DFS? So here the DFS stands for distributed file system. So it's going to have in your distributed file system, which is going to take care of that one. So here it's going to have the distributed file system. DFS stands for distributed file system, which you're going to have. Okay. So this is how your MapReduce intelligence services is going to work. So next comes how it is going to work with respect to task execution. So when you talk about the execution of the task, so the execution of the task will be taken care by your execution service. Okay. So it is controlled by the max execution service architecture. So this is the typical architecture which you are going to have, the MapReduce execution service architecture. So here the execution of task is controlled by the MapReduce execution service. So here the components which are there, like your command queue and job and task information. So that will be taken care by your command thread or report thread or completion thread. So, okay. So now these things, what it is going to have. So these components play the role of the worker process. Okay. These components which are there will be working as a worker process in the Google MapReduce implementation. Now here, so whatever the execution service architecture is there, so that is taken care by your worker process in your Google MapReduce implementation. So here the service architecture which you're going to have, that is execution service architecture. So what it is going to manage, it's basically manages the execution of map and reduce task. So because I have to map it to the work. Okay. So after working that one, so you have to make a shuffle of that particular work and I have to sort it and I have to go to the reduce phase. That's what we have discussed in the previous classes. Okay. So now here, what will happen? So the execution, once it is going to perform other operations such as sorting and merging of intermediate files. Now, once these things, so it is going to be into the sandbox environment. So that it is when it is going for the sandbox environment. So that is nothing but one sandboxing environment which you're going to have. So what is this particular sandbox is all about? So it is nothing but your testing environment which you're going to have. So our white box is nothing but the testing environment. So what is the task of the sandbox? The task of the sandbox is what? So it is used to isolate the untested code changes and experimentation for the production environment or repositories. Okay. So now it is nothing but your testing environment is nothing but whenever we are discussing with respect to the cloud, it is nothing but the virtual. Okay. So it is nothing but the virtual machines where it will be running, executing without affecting any of the network resources or any of the applications. So now, if we take about the architecture, so how the service is internally organized. So the service is internally organized as shown in the figure. So they are basically, it is going to have the three major components. What are those three major components? One is the MapReduce scheduler service, which you're going to have. So that is at the left side of your picture. So that is your MapReduce scheduling service. One is your executor manager. So that is this one. It is your executor manager. Another is your MapReduce executor. So the third one will be your MapReduce executor. So I can see it here, MapReduce executor service. It is a wrapper. It is also a what? It is also a wrapper class for executor manager. So this will be also a wrapper class for your executor manager. Okay, which you are going to have. So that is how it's going to work. So if you take the MapReduce scheduler service, so it interface MapReduce scheduler service will interface the executor manager. So interface 3, it is going to interface as you can see it here. So it is going to interface the arrow marks, that the two side arrows which are going to have. So it is going to specify that it is going to interface. So what it is going to interface? So your MapReduce service is going to interface the MapReduce executor service. So this is the interface. So this is it going to interface it. Okay. So now with the middleware. Okay. So this particular Aneka middleware, so it is going to have the MapReduce schedule service. It will act as an interface. Okay. So now once it is done, so your executor manager, which is there at the bottom, okay, so it will be in charge of keeping track of the task being executed. So your executor manager is there, right? So what it is going to make? So it is going to keep track of, it's going to keep track of the task being executed. It keep tracks of task being executed. Okay, so it keep track of the task being executed. So how it is going to execute? So it is by executing by demanding the specific execution of a task to whom it has to refer to. So it has to refer to whom, it has to refer to the wrapper class. So what is the wrapper class for executor manager? The wrapper class for your executor manager is your MapReduce executor service. Okay, MapReduce executor service is the wrapper class. So now, so what it is going to send to the Aneka middleware? So this will be sending the statistics about the execution back to the scheduler services. Okay, so whatever it is happening inside the executor manager, so that will be taken, whatever it is happening, that will be those information will be taken care by your MapReduce executor service. Once it is taking the MapReduce executor service, whether that particular given task is completed or not. Okay, so now to whom it has to report to? So it has to report to the MapReduce scheduler service. Okay, so what it is going to report? So it is going to report the statistics. So what is the statistics? Whatever the scheduler, whatever the process, whatever the task you have been assigned, whether that particular task has been completed its operation or not. So whether it is requires some resources to complete it. So these things it is going to keep in mind. And after having all those things, it is possible to configure more than one MapReduce executor instance. Okay. So here you can see it here. So here only one MapReduce executor service is mapped with the MapReduce sharing service, but it is not the same in the real time. So you can have the multiple MapReduce executor service. The same environment may be there. Another MapReduce executor service I can have here. So I can have another MapReduce executor service. So if you take the MapReduce executor service, MapReduce executor service, if you take, so even it that will be having the executor manager. So your executor MapReduce execution service will be wrapper class for, this will be wrapper class for your executor manager. So you can have the multiple instance of that one. Okay, you can have the multiple instance of that one. And if you have the multiple instance, what is the advantage? So if you have the multiple instance, it will be helpful in case of multiple core nodes where more than one task can be executed at the same time. So if you have the multiple nodes, so multiple tasks can be assigned to that particular nodes and you can complete the task parallelly. And once you are completing the task parallelly, obviously what will happen? The task will be completed at the earliest. Okay. So next comes, once this is how your MapReduce execution service architecture is going to work. So next comes the distributed file system support. How you can see it here from the figure. So you can have here, right? So it is distributed file system implementation is there. So you should know that. So what type of support it is going to provide. So if we talk about the distributed file system, so we have to look into the what type of support that is going to give. So what type of support that is giving, that we have to see that one. So that will be discussed next. So what type of support your distributed file system support is going to provide. 1 minute. Okay. So next we'll go with the distributed file system support. So now, So this particular distributed file system support which you are going to have, so that is going to be different from the other programming models. In that one, what is not, they are not going to give, that it is not going to give the default storage service for storage. So that we have seen. So whatever the MapReduce technique, we have been MapReduce implementation of Google MapReduce. So that is not going to provide you the facility of default storage service, okay, for storage and data transfer. So, but it is used, but what type of storage system it is going to use? It is going to be make use of the distributed file system implementation. So, but it is not the case with your Aneka. So here in Bitwarden, so for this particular reason only, the requirements in terms of file management are significantly different with respect to the other models. So if you are going with the file system, as we have said that other is hierarchical model is there, block model is there, stream model is there. Okay. So you after, apart from this one, other file systems are also there, like journal file system or JFS file system are there. So different file systems are used for different applications. Okay. So here what we are going to, it is not supporting. For what purpose? To store and transfer the data. So, but what it is going to be used, your MapReduce is basically using what? It was basically using the MapReduce default distributed file system implementation. Distributed file system is the next question. So, if we take the reason for that one, so the requirements, so the requirements in terms of file management, so it is different for different models. Okay, so if you talk about the file management system, so the file management are totally different from different with respect to a different model. So the file management, what is happening in your Windows file system, is totally different from file management which is going to happen in your Linux. Okay, so because when you talk about the Linux, it will treat everything in terms of files. Okay, so even your exe file, it is going to treat that as a simple file. That's it, nothing else. Okay, so this is going to have the different uh, models. So when you are going to make use of the different MapReduce programming models, so different MapReduce programming models requirement is different from different file management system. So now if we take the MapReduce, which is designed to process large quantities of data. So actually why we are using the MapReduce? MapReduce was designed basically to process large quantities of data and to analyze it. So it is going to be basically used for large quantities of data, large quantities of data stored in files of large dimensions. It is going to happen. So now, for that particular reason, what will happen? The support provided by the distributed file system. Okay, so when you're talking about distributed file system, so there we are going to assign those distributed file system for the different nodes. Okay, so for storing the data, that is more appropriate at that time. So that's for that particular reason. So the support provided by the distributed file system can leverage the multiple nodes for storing data. So that it can use that one. So it can leverage that particular option to for storing the data which you are going to have. Okay. So now when you are going to have this particular part, okay, so what it is going to provide? So if you talk about your distributed file systems, so basically the distributed file systems is going to provide you a high availability. So it guarantees high availability. High availability means what? So it can be accessed 24/7. So it is available all the time. So available whenever it is going to available. So 365 to 24/7, 365 days, that particular file system should be available. So now when you are going to have that particular types of file system for 365 days and 24/7, what it is going to provide? So it is going to have the better efficiency. Okay, by means of what? By means of replication and distribution. So it's going to have the better efficiency by means of replication and distribution. So now what your original MapReduce implementation is going to assume. So moreover, if you take the MapReduce implementation here, so your original MapReduce implementation, what it is going to assume. So it is going to basically assume the existence of distributed and reliable storage. So it is going to assume the existence of distributed and reliable storage. So for that kind of purpose, basically it is going to make use of the distributed file system for implementing the storage layer in natural. So for this, but that is the reason why it is going to make use of the distributed file system. So if you talk about the hierarchical file system, it will be in hierarchy. So that you have been seen in your Linux. Okay, so that will be in hierarchy. So in distributed is nothing but what? So the all file system, this is a master file system if you take. So it is not going to be stored in single place. So all the file systems are distributed in different places. So it is, if it is taken this one as the file system, which is going to have the main one. So it is going to have the first one, file system 2, file system 3, and file system 4. So that's what is going to happen there. Okay. So now when it is the Aneka MapReduce data file format. So if you look into this particular figure, so Aneka provides the capability of interfacing the different storage implementation. Okay. So your level of integration required by MapReduce requires the ability of performing the different tasks. What are the different tasks it is going to perform? One is retrieve the location of files and file chunks. So first you have to retrieve the files. Okay. So first you have to, whatever the file system you are going to have here. So it has to basically provides two different functionality. So what are the two different functionality it has to perform? So what are the two tasks it has to perform? One is, so one task which it has to perform is retrieving the location. So it is going to retrieving location of files and file chunks. Okay, so it has to retrieve the location of files and file chunks. So other function it what it has to perform is accessing, has to access the file, receive. So these are the two operations what it is going to perform. So now whenever you are retrieving the location of files, that is the first operation what it is performing. So that will be useful for the scheduler for optimizing the scheduling of map. Okay, wherever the file is located, so I have to locate that particular file and I have to make that particular file to be opened, and where that particular file is located, because I don't know in the distributed file system where that particular file is located, because it is distributed all across the globe. So I don't know in where it has been located, in which date located. So if you take it may be located in Asia, or it may be located in Australia, or it may be located in North America. Okay. So now the second operation which is going to happen here, so is accessing the file by means of the string. So what type of operation it has to do at the time? So it has to perform the reading and writing operation on the files, right? So it is nothing but what in terms of the normal language when we are talking. So it is nothing but the IO operation, that is input and output. So that particular operation has to be performed on the data files. So now if we talk about the distributed file system, so whenever you want to access the file, okay, so whenever you want to access the file, you require the network. So you might require the access of the network. If your file is not located in the local node, so if you are where you are working, so in that particular system only, if that particular file which you require for scheduling, if that particular file is not available in the local node, then where I need to check for that particular data, I need to check for the data in the other node. So now if I have to access the other node, first thing is I want the network to be there. Okay. So if that particular data is, or if that particular file is not available in my local node, then I have to access that particular system through So that particular system has to be happened through the distributed file system. So here in this one, what will happen here? So here, this is the Aneka MapReduce data file format, which you're going to have. Okay. So in this one, what will happen? Our Aneka provides the interfaces. So it was going to provide the interfaces that allow performing such operations and the capability to plug different file system. Okay. So on top of this, what will happen? It is going to have the low level interfaces. So as you told here, there are classes of which is going to have the sequence reader and you're going to have the sequence writer. So what they are going to provide? Basically, they will provide the sequential access. So sequential access is nothing but what? It is going to access file by file. Okay, sequential access for reading and writing the key value pairs. And they expect the specific file format as shown in the figure. Okay. So now, basically, if you take this particular Aneka file format, it's going to have the header, right? So on top of that one, it is going to have the header there. So it is composed of the header. You can see it here on top. So it's going to have the header. So this is nothing but the header. So the header is of the 3 bytes magic number. So it's of 1 byte version. So it's going to have the 1 byte. So it is basically used to identify the file and the sequence of record blocks. That means once after this particular block, which block I have to refer to. Okay. So that it is going to refer to. So that is nothing but your similar to your linked list. So whatever the file system we are going to use, the file system, basically it is going to be stored in form of linked list in your file handling. Okay. So that you should know internally how it is going to be stored. So basically it is going to store with respect to the linked list. So all of you have seen the linked list, right? So in the same fashion, the data will be stored inside your file system. So if you want to have the starting of the file, the starting of the file should have some address. So depending upon that particular address, it is going to start from there, reading the data and sequence of record blocks, which has to be taken. It is going to taken with the help of the key lock pair. So you're going to have the key lock pair. So with the help of the key lock, it is going to access that particular data. So now if you take the header, so the header integer record block. So whatever the records you're going to have, so it is going to specify that what is the length of the block. So length of the block is there. So the second, it is going to tell what is the length of the key. So what is the key byte array you're going to have. The third block, it is going to specify. And what data it is going to store, it is going to specify by fourth block, which is nothing but your value byte array. So that is what is the value which has been stored there. So if you take the adder of your record block, so it is going to basically the first composed of 4 bytes. Okay, so it is going to have the 4 bytes. So the first 3 bytes represent the character sequence SEQ. So the first 3 bytes which you are going to have, so basically it represents the sequence number. So what is the sequence of the data which is to be there? And the fourth byte identifies the version of the file. So what type of file version you are going to have, it is going to have. Okay. So the record block is composed as follows. So if you take the record block, so in the middle, so if you take the record block, so what the record block consists of? Basically, the record block composed of follows. So you can see the first 8 bytes are used to store 2 integers representing the length of the rest of the block and the length of the key section. So what is the length of the block it should have, and how much size of data it can store? It is going to have that one that is specified by 4 bytes. And what is the key pair? So what is the length of the key? So if you take when you talk about the MapReduce, what will be the key? So it is going to have the sales in the particular city. For example, I am telling that. So what is the sales of a washing machine in Delhi? So Delhi and washing machine will be the key pair now. Okay, so those key pair will be stored in the next byte. Okay, in the second block which you're going to have. Okay, so now the remaining part of the block, what it is going to store? So it is going to basically store the data of the value composed of the pair. So it is going to have the sequence reader and sequence writer classes. 2 classes will be there. So one class is used for reading the file. One class is basically used for writing the file. So it may be written in .NET. So whatever the Aneka we are discussing, the Aneka is normally support your .NET framework or C#. Okay, so when you talk about the Aneka, Aneka, basically here we are going to make use of C# or .NET. Okay, so that we are going to make use of. So now all these facilities which you are going to have, either it may be length of the block or whether it is the length of the key you are going to have, whether you are going to have the sequence reader or sequence writer classes. So what is this particular class is going to be hold. So those things will be given by your library interface of your .NET. So all these are supported by your .NET framework. So since MapReduce jobs operates very often, and the data which you're going to have, that has to be designed to read and write the text file. So you are going to have the program file handling you are going to have. With the help of the file handling, the same file handling, you are going to access that particular file, and whether what operation you have to do on that particular file, whether you have to do the write operation or whether you have to do the read operation. So that will be taken care by that one. Okay, so in case of read operation, what will happen? Each pair is represented in the line of the text file. So when I tap on the read operation, whenever you are reading the data from the file, so each file, so the read from the file. So if you take the read operation, so in the read operation, what will happen? So in terms of read operation, represented by line in the text of file. So it is represented by line of text of file. So it is represented by line of text of file. It is going to have here. Okay. So that's how. So now here, what will happen when it is going to represent the line with the key of the text file? The key will be automatically generated. So here the key is automatically generated and assigned to the position in bytes. Okay, where that particular line has to start and where it has to end, because the pointer has to keep track of the different blocks. Okay, when you are going to have the 1 MB, as I told you that if you take 1 MB of file size is there, for example. So if my block size is 4 KB, for example, I'm telling. So if I have 1 MB file size, how many blocks you require if I am going to have the 1 MB file size? So if you take 1 MB, so that will be 1024 KB, right? So 1024 by 4. So that means 4 2 4 3s are 12, 231. So not 231. 4 2s 8, 8 2 12, 4 5 6. Okay. So totally 256 blocks you require to store 1 MB of file. So what will happen at the time? So all these 256 blocks need not be there in a single node. So it may be distributed in a different node. So now when you are accessing to the different node, you would have the option of reading the file from the distributed node. Okay. So now depending upon the record, so I should have some sequence number, which one has to read first, which one has to read second, which one has to read third. So it is going to record you the interface between the sequence reader and sequence writer class. So this is how it is going to happen. So you're going to have the sequence write class and sequence ref class you're going to have. So that will take care of your reading and writing the data from the class. Okay, so the next topic which you're going to discuss here, parsing, how the Aneka logs is going to be parsed. So how the parsing has to be done with respect to the Aneka. So next comes the question, what do you mean by parsing? So anybody having any doubt till now? So you should know the file handling system. So anybody having any doubt? Okay. So now when it comes to the parsing Aneka logs, what do you mean by parsing Aneka logs? What it basically do? So basically it is going to divide all the blocks, and all the blocks will be described perfectly. So whatever the Aneka logs you are going to have, so Aneka is going to have different logs, like which task has been reduced, how much file has been read, so what are the data it has been read. So it is going to prepare some log, right? So at what time that particular particular file has been read, at what time that particular file has been written. So now this has to be maintained. Okay, so when it is maintaining, when it is processing the large quantities of data, so whatever the logs it is going to have, so in many cases what will happen, so that will be stored in semi-structured form. So that is logs are web pages. That is semi-structured means what? So it's not completely structured. It won't be in the row and column format. So but whatever the web pages it is going to access, so that particular web pages address, it is going to store it in some file. So now, in order to demonstrate how the program real applications work with Aneka reduce, so we have to consider a common task called as log parsing. So common task has to be learned, and it has to be log parsing has to be done. So for that one, what we need to do for that particular thing, log parsing has to be implemented. We have to design a MapReduce application in such a process that so that should process the logs produced by the Aneka container. Okay, so we have to design the MapReduce application itself when we are designing itself. So what that particular application has to do, that application has to process the logs. That means it has to list the logs. What are the web pages it has been accessed, at what time that particular access has been done, what type of event that particular scheduler has done at that particular time. So now who has to take care of that one? That logs has to be done by your Aneka container. And after that one, after having that particular logs from the Aneka container, it has to extract the summary information. So what information it has to summarize? The cloud information. So from which cloud I have taken that particular data, from where I have retrieved that particular data, and how that particular cloud is behaving, whether it is behaving normally, whether it is secured one, whether it is unsecured one. So now that is what your parsing the log is going to tell about. So in this particular section, we discussed in detail the problem to be addressed and design the MapReduce classes that are used to execute the log parsing and data extraction operation. Okay, so that's what is done. So Aneka components produces a lot of information. So whatever the information that is daemons, that is background process it is going to have, what are the container instances it is going to have, and what are the services it is going to provide, like MapReducing service or execution service, MapReduce scheduler it is going to have, and which one is the wrapper class that it is going to tell. So those lot of information which are going to have, that will be stored in the form of log files. So all these information will be stored in the form of the log files. And whenever the container is going to have, the container is going to store only the important information or relevant information. The most relevant information is basically stored in the container instances logs. So you're going to have the container instances in the node. How many instances? Different depending upon the different instances. At different node, that particular instance will be running. An instance is nothing but the virtual machine. Okay. So when you're going to have that particular instance logs, so what that particular log is going to contain is going to contain the information about the application. So that log contains the information of the applications that are executed in the cloud. So where it has been executed, so that particular information it is going to retrieve and it is going to be stored there. So you can have this particular parse and you can get that particular parse. Okay. So that particular component, or you can get that particular logs information, and you can extract that particular logs, and you can use that particular information about the execution of applications and how that particular service is used in the log cloud. You can use it. So the entire framework which you're going to have, it is going to leverage the log4net library, okay, for collecting and storing the log information. So in the case of Aneka containers, the system is configured to produce a log file. Basically, it is going to be partitioned in chunks every time the container instance starts. Okay. So whenever the instance starts, so that particular log will be started. So as I told you in the Amazon Web Services, we have created an instance and we have deployed it. So once you deploy that one, it is going to keep the log that at what time that particular instance has been started, and we will keep track of that particular information. So the more is the information what is going to be happened, so that will be contained in the log file, and it can be customized in their appearance. So the currently following what they are going to have is date, month, and year, and hour, minutes, and second. Okay, so DD stands for date, month, and year. So followed by your at what time, what date it is going to be accessed, that particular log has been created, what is the time it has been created, and what type of information it is going to have, whether that particular form log message is going to have the debug or schedule service or submit application you're going to have, application you have submitted for running. So those are the messages it's going to display. These are some of the examples of formatted log messages. You can see it here. It is like 15th March 2001 at time 10:02 debug has been done. on what? So it is going to schedule service. Service has been scheduled. So what type of scheduled service is going to have it? Handle the submit application. So whatever the application you have been submitted, so that should be handled properly. So these are the some of the examples. So in this content. So now some of the times what will happen, that will be stored in the compress form. So when you're going to have the compress form, I need to extract the logs from the following. So what are the extracts from such logs is the extracts from the logs. So what are the information it is going to extract? So first it has to extract that what is the distribution of log messages according to the level of information which you are going to have. And depending upon the type of the components which you are going to have, how the distribution of log messages has been done. That has to be done. Okay. So for that one, you are going to make use of the map and reduce. So first it is going to have the long string long. So the information can be easily extracted and composed into a single view by creating a mapper task. So we have seen across the instances creation. So how it is being done by using the single view of your creating the mapper task. After that one, the count it is going to take. So how many occurrence of log levels has been done and how many components names are there, and it is going to have the simple key pair. Key value pair is there in the form of level name and 1. Okay, key comma pair. So level name is the key. So pair is 1. Key value pair is 1. So and then on what component on how many occurrences it is going to have. So that will be where it will be assigned by your reduce task or component name comma 1 for each of the occurrences. So now the reducer task, what it will do, it will simply sum up all the key value pairs that has the same key. Okay. So whatever the log it has been accessed, the same log name site it has been accessed, that is going to list out, and what type of operation it has been done, whether it has done the debug operation, whether it has submitted the application, whether it has executed the application, it is going to look after that one. And it will sum up all the key value pairs as we have discussed in the last class about the example. So like how many mangoes are there, how many oranges are there. The same time it is going to and the structure of the map and reduce functions will be and string comma long. So reduce is another thing which you're going to have. So this is going to have the string comma long. So the type of that particular information which you are going to have once you have been listed out. Okay. So the mapper class is the mapper class which you're going to have is going to receive a key value pair containing the position of the line inside the P. So next you are going to have the log messages as the value component. So in the reducer class is going to sum up all the key pairs as we have explained previously. The same thing it is going to do. The mapper class is going to receive the key value pair, contain the position of the line inside the file as a key, and the log message as the value of the component. And with the help of that particular position and the log message, it's going to generate the string representing the log value and the component. And the reducer class, what is going to do? So the reducer class is going to sum up all the key value pairs that have the same name. Okay, since it is in a semi-structured way, so it has to modify that structure of the file. So since it is a semi-structured manner, so it has to modify the canonical structure, and it is going to perform both the analysis on that particular data at the same time. So instead of developing the two MapReduce jobs. So and then the reduce class, what is going to do? So the operation performed by the reduce class is same in both the classes. That is going to reduce with respect to the key value pair, and it's going to sum it up, or it is going to when it is going to sort it and it is going to sum it up as we have discussed in the previous classes. Okay, and it is going to generate it by the two jobs. So that is why it is possible to combine the two tasks performed by the map function into a single one wrapper class. So that's what your Aneka is going, how it is going to work with respect to the with respect to the MapReduce programming model, how your Aneka is going to work. So the MapReduce is actually a Google part. So, but whatever the MapReduce we are going to discuss here, it is with respect to